let's look at that second part there. The ray that forms the initial side of the angle is rotated around the origin, with the resulting ray being called the terminal side of the angle. So we're saying this. We've got some angle. We know it's centered at the origin. We know that initial side is on the x-axis and it's not moving. And we have this other part called the terminal side. That terminal side is what moves. The initial side stays. The terminal side moves. If I were to look at this graph here, that definition is saying if I lay my pencil on the initial side and rotate it, that's where I get the terminal side. Your terminal side can rotate all the way around the graph. It could rotate multiple times. Will the initial side rotate? No. Where will the initial side always be? On the positive side of the x-axis. If the initial side is not on the positive side of the x-axis, is it in standard form? No. If an angle's not in standard form, we're not going to mess with it. We are only dealing with the standard position. The initial side is always on the x-axis there. The terminal side moves around. An angle can be two things. It can be positive or it can be negative. A positive angle, let me erase what's on here, or if I can. Oh well. A positive angle is the blue line there. A positive angle starts at the initial side, it starts at your x-axis, and it moves counterclockwise. What's counterclockwise? Yeah, do it with your hands because you got to be able to know this. Move your hands counterclockwise. There we go. Okay, good. Counterclockwise creates a positive angle. So again, if I have my pencil and I'm on the initial side and I move counterclockwise, that's the positive direction. How else could you remember that as positive? If you're on the initial side, do you start by going up or down? Up. That's the positive direction. A negative angle is the opposite. Negative is the red line there. A negative angle is moving clockwise. So a negative angle starts on the initial side and moves what way? Down, and it can rotate all the way around however many times. What I have circled there, those little arrows, those are going to be really important. Those are showing your direction. Without those loops or arrows, you don't have to have the arrow on it. Without that, you don't know what direction you came from. You have got to draw those arrows. Okay, on your whiteboards. Draw me a positive 120-degree angle. Like a positive 120 degrees. You would do your x-axis and your y-axis. 120 degrees would be somewhere past the 90. And you need that little loop, curve, arrow, whatever you want to call it, to mark your direction that you went positive 120 degrees. I want you to draw me negative 45 degrees. Make sure you have your x and your y-axis. Draw negative 45. If you were to do negative 45 degrees, x-axis, y-axis, we're going clockwise, negative 45 degrees. A negative angle literally has a negative sign. All right, let's look at the next vocabulary. This one might be the most difficult to understand. Coterminal. Two angles are coterminal if they are in standard position and share the same side, the same terminal side. Here's what that means. Look at the red 120 degrees. The initial side is on the x-axis, and the terminal side rotated, and we've got positive 120 degrees. But we've also got the green up there, the negative 240 degrees. So the negative 240 started at the x-axis and rotated clockwise going down 240 degrees. What do those two angles have in common? That is true. What else? They share the same side, that terminal side, and that's the really important part. Two angles are coterminal if they share the terminal side. What's terminal mean? The end, okay? The terminal side is where the angle ends. The red 120 degree angle, it ended here. The green 240 degrees went down clockwise and ended here. They ended at the same spot. That makes them coterminal. Okay, you might want to make note of that. Make sure you really know that. You can circle. They share the same terminal side. You could put yourself a little note there. Coterminal means they end at the same spot. Now here's what's tricky with coterminal angles. 120 degrees has negative 240 and they are coterminal. And a couple of you noticed if we took the negative off the 240, if we took the absolute value, 120 plus 240 equals what? 360. Why is that significant? It's the whole circle. If you went part way in the positive direction and then part way in the negative direction, and they meet at the same spot, you've covered the whole circle. Okay, so that 360 is significant. What if I wanted an angle that ended up right here, just like the 120, but I didn't want to go in the negative direction? Ideas? If I wanted an angle that ended up right here at the 120 mark, but I didn't want to go in the negative direction. Very close. You're very close. What was your reasoning for 120 and subtracting 360? Yes, thank you. Very good. If I wanted to go in the positive direction and get back to that 120 degree spot, I could go 120 degrees plus 360. Why would I add 360?
Because you're still going.
Because I'm going all the way around the circle. I didn't want to go in the negative direction because that's just what I chose. So I could go like this, okay? I'm starting at that black dot. That's my my initial side. And I'm going to go all the way around the circle. How many degrees is that?
360.
360. And keep going 120. Did I get to the same spot? Yeah. So let's say 360 plus 120 equals what? 480 degrees. So 480 is coterminal with 120 because it ended in the same spot. Is 480 degrees coterminal with negative 240? Yeah, because they end in the same spot. Suppose I wanted to keep going in the negative direction. I could take the 240 and subtract another 360, another revolution. And that would put me at 600, is that right? Negative 600, and we'd be at the same spot. Okay, let me practice that.